All right, so we talked last week about interval notation. Remember two things that you want to keep in mind. The first thing is if it's equal to, we give it a bracket. If it's not equal to, it gets a parentheses. Infinity and negative infinity always gets a parentheses. And when you write your interval, it's always the smallest number to the largest number. So for question A in our Bell work, I'm going to write it as -2 to 7. -2 gets a bracket. 7 would get a parentheses. Who had that for A? For question B, it's -1 to 2. -1 would get a parentheses. 2 would get a bracket. All right, for question C, this says less than. So because it's less than, that means it's coming from negative infinity. So negative infinity is the smallest number in the world. So it would go negative infinity to 0. Infinity always gets a parentheses, and because the 0 is not equal to, it's also going to get a parentheses. So this is what your interval should look like. And then for question D, this is greater or equal to. So that means it's going towards the largest number in the world. The largest number in the world would be positive infinity. So we're starting this interval at -6 and going to positive infinity. Because this is equal to, the -6 gets a bracket. The parentheses will get an infinity. All right, any questions about how we work through that? So there's two inequalities that we did not get a chance to finish on Friday. I'm going to put those up and give you a chance to solve them and then write your answer in interval notation. So go ahead and copy down questions 3 and 4. Solve it and write your answer in interval notation. So I'm passing back homework. I'm gonna put it in the front of the row. If it's not yours, that just means pass it back. Because it's somebody needs the row. Just so I can pass it back a little faster. All right, let's go ahead and work through it together. So our first step would be, so I like to always have my x's on the left. So instead of subtracting 3x to the right, I'm going to subtract the positive x to the left. So let's subtract x. And that gives you 2x minus 1 is greater than or equal to 3. And then I'm going to add 1. So 2x is greater than or equal to 4. And then lastly, I'm going to divide by 2. So my inequality is x is greater than or equal to 2. And because it's greater than, that means we're starting at 2 and going towards the largest number in the world, which is infinity. Infinity always gets a parentheses, but that 2 is going to get a bracket because it was equal. And that would be the answer I'm looking for on the test next week. For question 4, I'm going to subtract the 2, which gives me negative 3x is less than or equal to 3. Divide both sides by negative 3. Now remember, when you divide an inequality by a negative, what do you have to do with the inequality? You have to flip it. So that's going to change from a less than to a greater than. So it'll be x is greater than or equal to negative 1. So my interval would be negative 1 to infinity, parentheses, and a bracket. All right, so that's the end of Appendix 9. That's all of Homework 3. So at this point, Homeworks 1, 2, and 3 are done. We've covered everything in those 3 homeworks. Now we're moving on to Homework 4, which is Appendix 10. Before I do that, this is just a reminder of the assignments that are due this week. You have 4 assignments through. You can turn them in till the day is due and then the next day for full credit. But you have to turn it in during your class period to still get that full credit. Homework 2 is due today. So you can turn it in today, or you can turn it in tomorrow during second period, because it's the second period, okay? After that, you can still turn it in. It's just you lose 20%. So it goes from 50 out of 50 to a 40 out of 50, which is better than 0 out of 50. So I'm not saying not turn in the homework. It's better to turn it in late than to not turn it in at all. Okay. So we have finished all of the questions or all of the material for homeworks 1, 2, and 3. Homework 3 is interval notation and solving inequalities. All right, so now we're going to start homework 4, which is Appendix 10. So if you're titling your notes, this is what it's titled. So Appendix 10 is about roots and rational exponents. A rational exponent simply means that the exponent is a fraction. That's all that means. All right, so here's the definition that you need to copy down, and we're going to do some examples to kind of work through that. So we're going to talk about how do you write a radical or a root as a rational exponent, and what does that mean exactly? Okay. All right, so let's go ahead and copy down this definition, and then we'll talk about what that means. The numbers. Okay, so this says the nth root of a number also means a to the power of 1 over n. So what that means is, if you have, let's just pick one of these perfect squares. Let's say 25. If you have the square root of 25, that can also be written as 25 to the power of 1/2. That's the exact same thing. So you can write a radical as an exponent that has a fraction. The one thing to keep in mind is that whatever your index is, and your index is this number here, that is going to always also be your denominator. All right, so now let's look at a perfect cube. So if we have the cube root of 8, that can also be written as 8 to the power of 1/3. And then lastly, if you have 16, let's start with an exponent, 16 to the power of 3/2. What this means is we're doing 2 operations to this 16. The denominator is the root, the numerator is the power. So this 2 tells me that I'm taking the square root of 16. That's what that 2 means. Whatever is in the denominator is your root. So it's not the cube root because 3 is in the numerator. It's the square root. We're taking the square root of 16, and then we're taking that answer to the power of 3. So this can be written as the square root of 16 to the power of 3, or you can also put that 3 on the outside. Okay, so we're going to work through some examples. We're simplifying some radicals today. And we'll spend 2 days on Appendix 10. Yes, Deborah. The 3 in this example is my power. That's the power. And the 2, we'll call that the root. So the numerator is your power, the denominator is the root, or the index. I think there's a box by the pencil sharpener. All right, go ahead and copy down these 3. Wait, before you copy these down, I want to talk about something else before you copy this down. Couple more notes before we jump in. Let's talk about negatives. If you have a negative, I'm going to say -1, and the index is an odd number, then we can actually take that negative out. So if I take the cube root, when I say odd, I'm talking about an odd number, like a 3, a 5, a 7. So the cube root of -1 is -1. But if it's even, so if it's an even number, such as 2 or 4 or 6, then we're just going to leave it. We're not going to simplify it. So that is just going to stay, whatever that index is going to stay, and we're not going to simplify it. So we're going to do a couple of negatives today, and then we'll finish it out tomorrow. So I wanted to talk about that. So we're just going to say this cannot be simplified. cannot simplify further. So we can simplify it if the index is odd, but we can't simplify it if the index is even. So now that we have said that, now we're ready to get started. So that's all the background to this unit. So now we're ready to fly. Go ahead and copy down 1, 2, and 3, and we will simplify those. Okay, so the first few are pretty simple. So for example, we have the square root of 49. So the square root of 49, because I'm looking for a pair. Anytime, so this tells me if it's a square root, I need a pair of numbers. Two numbers that are the same, that are factors of 49. And we all know that the square root of 49 can be written as the square root of 7 times 7. And because I have a pair, my answer is just 7. For number 2, though, now instead of looking for a pair, I need a group of 3. And I didn't write the perfect cubes on the board. I'm going to write a couple of them. So 2 times 2 times 2 is 8. I'm only going to write the couple. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. And I don't know the rest. I think 6 times 6 times 6 is 216. Is it? Okay, so we can stop there. These are called perfect cubes, and of course they continue. So 27 is a perfect cube. So the cube root of 27 can be written as 3 times 3 times 3. And because I have a group of 3, it simplifies to just 3. Now, when you see a negative, we need to split that apart to the cube root of negative 1 times the cube root of 8. And if we go back to what I said previously, the cube root of negative 1 is actually negative 1. So this equals negative 1. And the cube root of 8 is a perfect cube. That's 2. So our answer would be negative 1 times 2, which is negative 2. So that would be my 3 answers. All right, let's look at questions 4, 5, and 6. Go ahead and copy this down, copy these 3 down, and then we'll work through these together. All right, so I'm not going to write the perfect fours on the board, but 16 is a perfect fourth. It's actually the smallest perfect fourth. So this can actually be written as the fourth root of 2 times 2 times 2 times 2. And make sure when you're writing your indexes that you don't make them too big, because it should be kind of small, and it really should be in that little hook. All right, so do I have 4 of the same number? I do. So the fourth root of 16 is 2. Now for the negative, so these are two totally different answers. Whenever you see a negative, I want you to break it apart to the fourth root of negative 1 times the fourth root of 16. Remember, if this is even, it can't simplify. So this is going to stay like this. And we already know that the fourth root of 16 is 2. So my answer is going to be 2 times the fourth root of negative 1. When you have variables, just like numbers, you need groups of that index. So only because we're learning, and I don't know how many of you all remember this, I'm going to actually write it out with 8 x's. 2, 3, 4, 5, 6. Because that's what you really have. You have the fourth root of 8 x's. And we have to make groups of 4. So I have one group of 4, and I have another group of 4. So with 8 people, I can make 2 groups of 4 with no one left over, which is why it simplifies to x to the power of 2. All right, now let's look at 7, 8, 9. And this has a 3. I keep forgetting to fix that. Well, that's a 3. Yeah. All right, so we're going to stop at number 11 today. So, and when there's more than one thing underneath the radical, we have to separate it out. So for number 7, I have 10 people. I always try to say people. And I need groups of 5. So I'm not going to write the letter Y 10 times, but you can if you want to. And circle groups of 5. So if I have 10 people, I can make 2 groups of 5 with no one left over. For number 8, I'm going to break it apart because there's 3 separate things underneath the radical. I'm going to separate it into 3. So I have the cube root of 125, the cube root of x to the 6, and the cube root of y to the 3rd. I'm going to look at each one individually. And we can see that 125 is actually a perfect cube. So the cube root of 25 is 5. If I have 6 people, how many groups of 3 can I make? So that would be x squared. And if I have 3 people, how many groups of 3 can I make? So that would be y to the first. And that's it. Generally, we always write our answer with the number first, and then the variables are in alphabetical order. All right, number 9, go ahead and try to do number 9 by yourself. So again, if I have 12 people and I'm trying to make groups of 4, I can make 3 groups. So that would be a to the third. If I have 8 people and I'm trying to make groups of 4, I can make 2 groups. So none of these had any leftovers. So now we're going to do just 2 more today. And we're going to review, well, what happens if you have more that are left over? So only copy down 10 and 11 because we're going to end with that today. I'm going to go ahead and actually take that off so I have some more space. When you don't see a number, what do you think that number is? 2. So the lowest index you can have is 2. So is a square root. We don't take a first root of anything. So the lowest index is 2. So when you don't see an index, it is 2. And you can always write that in there. So I'm going to actually write it in a 2. And there are 3 different things that we're taking the square root of. Okay, so I'm actually taking the square root of a to the 10th. And I'm taking the square root of just b. And I'm taking the square root of c to the 9th. So only a is a perfect square because I can take the square root and not have anyone left over. So if I have 10 and if I have 10 items and I want to make groups of 2, I can make 5 groups. So that would just be a to the 5th. But if I only have 1, I can't make a pair. So this entire thing is going to stay. And it's going to stay to just the square root of b. Now for c to the 9th, essentially what we're doing is breaking this apart to the square root of c to the 8th times the square root of c. Because I know that if I have 8, I can make 4 pairs, which gives me c to the 4th. But I'm going to have 1 left over that's going to stay. I did not mean to make it with so much space, so I'm going to rewrite my answer. So it's a to the 5th, c to the 4th, times the square root of BC. And then lastly, for number 11, whenever you see a negative, I want you to break it apart. So I'm going to break this apart to the cube root of -1 times the cube root of, instead of 40, will any of these numbers that I have here go into 40? Any of these perfect cubes divide into 40? 8. So I'm going to actually break it apart to the cube root of 8 times the cube root of 5. And then I have the cube root of 14, which can be written as x to the 12th. And then x squared. Sorry, I'm going to have to rewrite this row because I can't fit it. Let me rewrite it. And these two, all three of these multiply to give me that cube root of 40. So I just broke that 40 down. And then x to the 14th can be written as, so I need the highest factor of 3, which is going to be 12. But then I have 2 left over. And for my y's, the highest factor of 3 would be what? Without going over 10. 9. So I'm going to write that as the cube root of y to the 9th times the cube root of y. Oh, wait, I got a little bit more space. I can write it. Okay, so now that we have kind of broken that down, it goes pretty fast. So this here, the cube root of -1 is -1. The cube root of 8 is 2. This cannot simplify. So I'm going to leave that. The cube root of x to the 12th is x to the 4th. This also cannot simplify. So I'm going to leave it. The cube root of y to the 9th is y to the 3rd. And this cannot simplify. So it's going to stay. So now we're ready to clean it up. Everything that has to stay can be written together. So all three of these can all go together at the end. All right, everything that could simplify can go on the front. So I'm multiplying all of these. This is going to go in the front. So my final answer is going to be -2. And then I have x to the 4th. And I have y to the 3rd. And I have the cube root of what's left over, which is what I have highlighted in green, a 5, an x squared, and a y. And that would be your final answer. Okay, just a reminder, homework 2 is due today. You can turn it in tomorrow for full credit. There's actually 4 homework assignments due this week.